You spun up a dedicated cluster and now your pipelines are running twice as long while your CFO wants answers on cost and ROI. The fix is not more tuning, it is choosing the right default. And that default should be serverless for about 80% of your workflows. Carve out dedicated only where it clearly wins on strict latency, always on pipelines, or highly specialized configurations. Think of your compute like transportation. Your serverless is your rideshare on demand. Your dedicated is actually owning the vehicle. Own it if you're going to drive all day. Otherwise, call the rideshare and stop paying for a parked vehicle. In 60 seconds, I'm going to show you a real timing overlay and the cost line so that you can defend this choice with numbers. First, a real quick story. A nightly flow that we had ran on a small dedicated jobs cluster. The first task waited for the node Stephen spin up. Idle gaps appeared between stages and the bill continued to climb. We moved that job to serverless and the first task started sooner. Operations handholding disappeared and the monthly bill flatlined. Now, let's stop hand waving. Here is a quick scoreboard that you can recreate on your own. So take a look at that. For bursty jobs, the warm benefit of having that is rarely there. Serverless wins on time to first byte ingested and bill stability. Your dedicated only wins when it stays warm and busy all the time. Now, open your Databricks jobs and create two jobs. Have the notebook read a medium delta table, filters, aggregates, and even writes it to a delta output. Choose your compute, then choose serverless. If your workspace offers a performance optimized serverless option, be sure you test both standard and performance. Now your job B is going to be your dedicated compute. Create a new jobs cluster, choose a small general purpose node, enable auto scaling, minimum workers to 1, auto termination about 10 minutes. You're going to avoid heavy library installs at job start. Now, run both jobs and record that time difference from run start to actually first task that it's running. Rerun both within 3 minutes and record again. Performance usually starts fastest from serverless because your serverless standard trades slower start for lower cost. Your dedicated only benefits when the cluster is staying alive in between runs. Your throughput and cost check, run 3 iterations on each job. Capture 3 numbers per run. Look at your start latency, your run duration, your DBUs for your billing, and keep it apples to apples. I'm going to give you a rule that is going to end that weekly debate on which you should use serverless or dedicated. But first, let's talk about archetypes and some hard carve outs. Okay, spiky batch and ad hoc. Here, your pattern is short windows with long gaps. So your default here is serverless standard. If startup time matters, use serverless performance for the few jobs that really need it. Your anti-pattern here is keeping dedicated alive just in case. You're just burning dollars while that dedicated cluster's sitting there really idle. Long stable pipelines is another pattern that you may have. So these are pipelines that run hours at a time or almost continuously. Here, your default is going to be dedicated, especially after profiling. Your control benefit, you have some fixed libraries and tuned executor settings. You have guardrails. You are capping auto scale swings, and big swings often mask some upstream problems. Next pattern is your specialized builds. You have custom runtimes, maybe some pinned drivers, private networking, GPUs, or maybe some special drivers. Here, your default is going to be dedicated. You're going to make it safe, restrict your instance type, you're going to enforce tags, and pin the image with a policy. Here you have a security veto path, and if security requires private networking or artifact pinning, then go dedicated. Keep the footprint small and documented, not the default for everything. If your job does not clearly meet one of these carve-outs, you are actually in serverless territory. And be sure that you're using some latency mini labs, right? Be sure that you're measuring. Measure twice, cut once. Do not guess. Your cut lines to set start latency target under about a minute for interactive, under 3 minutes for batch. And for your end-to-end target inside the business window, for example, you might use 10 minutes. 3 by 3. This is another example. 3 runs on serverless standard, 3 runs on serverless performance, and 3 runs on dedicated. So this is a pattern that you should use to test this. For every new pipeline that you're going to be running, and it doesn't necessarily fall into one of the patterns that we've discussed, be sure you're testing it and recording those differences so that you don't run up a bill unnecessarily. Be sure that you're plotting things like your start latency, your run duration, and your DBUs that are being used. Here are some noise guards. Run during a quiet window. Use the same data slice. Avoid cached reads if you're benchmarking I/O, and if dedicated is terminated in between runs. Be sure that you're noting all that and documenting it in your discovery sessions to figure out which one's best. If serverless meets both targets, then you're done. If only dedicated meets the latency target and it stays warm in your schedule, carve it out. If neither meets targets, fix your code or I/O before you're worried about changing the compute. Here's your cost mini lab. Know what you're paying for. Pull DBUs per run from billing for each job. Multiply by your DBU rate to get your cost per run, and then multiply by runs per day and per month to estimate what that cost is going to be for your workflow. Now, be sure that you're adding storage or egress if your flow moves data in and out of Databricks. Be sure that you're looking for some hidden creeps that you might need to check for. Things like auto termination is set too high, libraries that are installing at job start, silent retries and timeouts that are occurring, instant types that are larger than your actual parallelism. Stop and go patterns, they're going to tilt towards serverless, while your always on patterns are going to tilt towards dedicated. If this gap is small, choose the lower operations option. Your saved engineer time is real money, so don't neglect the actual time that you're spending babysitting or creating or running these pipelines manually. Plug your numbers in as you're walking through these various steps while you're doing your testing framework. Now, think about mitigation without changing your default. So for serverless, you're using performance mode for a small set of latency sensitive jobs. You're going to be pre-warm with a tiny scheduled run before the morning spike. So this way you're kind of warming up your cluster before the real jobs begin. That way everything is on and you don't have to worry about that spin up. Split heavy initialization so it does not block that first query that you're going to be running. For dedicated, use instance pools to reduce virtual machine provision time. Be sure that you are tuning your auto termination to match your burst window. Be sure that you are baking dependencies into your image and you're avoiding heavy installs at job start. The best thing about dedicated, your best advantage here, is that you can bake these dependencies into your image of your dedicated cluster. So fix the cold start first. Do not flip your entire strategy just for one job. Cluster policies. Cap maximum workers by tier. Force tags for owner, cost center, and environment. Be sure that you are restricting expensive instance types to only approved jobs. Budgets and alerts. Okay, this is an important stage here. Be sure that you are setting your monthly budgets by team. You're alerting on 7-day DBU drift above about 20%. Your weekly report should look at the top 10 jobs by spend with owner and last change. Your cleanup here, be sure that you are auto terminating development after any inactivity. Be sure that you're sweeping for orphan tables and temp paths, probably weekly. You could set up jobs that are doing this and giving you that reporting and logging it. Rotate logs to cheaper storage after about 14 days. Think of The same concept that you would use in S3. Be sure that you're utilizing things like that are similar to Glacier storage as opposed to your hot storage. And if you're using Azure, right, think of ADLS, you have cold storage and hot storage. So be sure that you keep those things in mind. These basics really prevent the surprise invoices that you hear these horror stories about. Anti-patterns to kill this week, right now. Dedicated for everything because of control. Don't do it, okay? Serverless performance for everything because it's quicker. Just because it's quicker doesn't mean you need it quicker, and doesn't mean that the cost actually justifies what you're trying to do here. Okay, auto scale maximum is set to huge just in case. Don't do it. Again, these are ways that you're going to really just asking for a high bill. No tags or owners. You want to be able to track where your cost is going? Be sure that you're setting your tags and your owners. Heavy pip installs during job start. This is one of the sure things that is going to kill latency. It is going to kill your cost. Now, kill 2 of these and you will have saved double-digit percents on your Databricks bill this month, which is going to make you look like the hero both to your boss and your senior leadership. Okay, here are some objections that you might hear. We tried serverless and it was slower. Well, your answer for this is, which mode did you test? Be sure that you are showing your start latency, your run duration, and your DBUs. If performance could not meet the cut line and your job runs continuously, that is definitely a dedicated carve-out for that. Now, here's another objection. We need full control of everything. That is not a specialized case. Document pins, drivers, network paths, use dedicated with strict policies so that the footprint stays really small. Here's another objection. Dedicated is cheaper in our region. Show your DBUs per run and your idle time. Stop and go workloads, you lose any price advantage to idle burn when those clusters are just sitting there open and not doing anything, right? So even though your cost per DBU might be lower, you're still paying for that idle time in between. So here's another thing. Do not argue feelings, okay? Don't argue gut feelings. Show the data. You're a data engineer. Use that to your advantage. Show the 3 numbers and let the chart win the room. Here are a few questions that you're going to hear in your next senior data engineer interview. And the answers to these are going to set you apart from the rest of your competition. Now, walk me through your decision framework for serverless versus dedicated when a pipeline has spiky nightly loads and daytime SLA. Let me know down in the comments what your answer to that is, and I will give you feedback. Or you could come over to our Discord and share your answers there. Now, next question. How would you reduce cold start pain without moving everything over to dedicated? Hint here, we just discussed it a few minutes back. Rewind, check it out. You inherit 120 jobs with no tags and mixed compute. What is your first week plan? Tell me, how are you going to help to make sure that that's efficient, effective, and still meet all the requirements of the business? Now, answer those cleanly, and you sound like the person who owns the bill and the SLA and is going to land that job. Download the Choice Decision Matrix right now. It is going to help you choose your Databricks compute in under a minute. It is going to help to cut your cold start waste, and it's going to help avoid the cost traps that hit most teams right in the gut. The link is on the screen and down in the description. And if you are ready to dive deeper into Databricks, check out this playlist right now.